Hello everyone, a very good evening all of you and a very warm welcome to you all to this wonderful practice session for fluid mechanics. So in today's session we will be discussing some previous year questions from the fluid kinematics which were asked in engineering science paper. So please do join me fast, and those who are already here respond me through the comment section if my audio and visual quality are fine, so that we can start the session at the earliest. If you have not attended my yesterday's session, कल हमने fluid statics के questions solve किए थे which were asked in engineering science, and today we will be discussing those questions from the kinematics which had been asked in engineering science paper. Alright, and tomorrow we will be discussing the questions from the dynamics. Alright, so please do join me fast, and those who are already here respond me through the comment section if my audio and visual quality are fine. Can you guys properly hear me? For those who are attending my session for the very first time, this is my quick introduction. My name is Chandrasekhar. I am mechanical engineering graduate from IIT Delhi. I have also cleared engineering services examination which is conducted by UPSC, and I have worked in Steel Authority of India Limited for a couple of years, and from last 10 plus years or 11 years I have been into teaching, guiding the students who are preparing for various competitive examination, and I am quite comfortable in these many subjects of mechanical engineering. Fluid mechanics is common for civil and mechanical both. So please do share the link of this session to all your civil and mechanical friends who are going to appear for GATE 2024 examination. Alright, and you can always connect with me through the mail ID. This is my official mail ID, chandra.shekhar7@byju's.com, and you can join Telegram if you are not part of my Telegram channel. I would like you guys to respond me through the comment section if my audio and visual quality are fine. Those who are here, please do respond. And my Telegram channel is Mechanical by Chandrasekhar. The link is also mentioned. You can join me on the Telegram as well. Okay. Once you become part of the Telegram channel, you will be getting these many benefits. Tomorrow at 7:30 p.m. there will be an interactive workshop taken by Richa ma'am. She will be guiding you to develop the right ideal strategy to become topper in GATE 2025. So those who are going to appear for GATE 2025 examination, this session is going to be very useful, and the registration is completely free, and the link to register yourself is already there in the description box. Join the workshop and develop the right strategy, because without a clear strategy, without a perfect strategy, nobody can achieve the objective. So the first right step is to develop the right strategy. And we are running some scholarship test also. This Sunday there will be a scholarship test for GATE exam. Based on your performance in the scholarship test, you can get the scholarship or discount up to 90% in our various courses. So not only on BYJU'S YouTube channel but also on app, our BYJU'S app, we are giving you the practice sessions for various examination. For an example, ISRO is going to be conducted on 7th of January. So you can attempt the quiz for specifically designed for ISRO. For that you need to download the BYJU'S app, and the link to download the BYJU'S app is already there in the description box. So use the bit.ly link which is there in the description box. Go through the description box once. In each and every sessions there is always a link, or there are always some important links which are going to be very beneficial for you. So here bit.ly link is there in each and every sessions description box. All right. So this is our results for ESC 2023 examination. I hope you guys are all charged up to explore the practice sessions. Please do let me know if you are all ready so that we can start our session. I cannot see your comments. Am I properly audible and visible to you or not? Shall we start? This is question number 1. It is from the kinematics. These are from the kinematics. Alright, crazy meteor. What will be the answer? It is beautiful. Del operator is a vector. Velocity is also a vector. Del dot rho v is equal to 0. That is the continuity equation or mass conservation equation. Hi Kumar. Good, good, good. What will be the correct answer? Under what conditions is the equation del dot rho v is equal to 0 valid? What is del operator? That is I cap del by del x plus j cap del by del y plus k cap del by del z. And what is the velocity vector? u I cap plus v j cap plus w k cap. If you take the dot product of these parameters, then this will be del by del x rho into u plus del by del y rho into v plus del by del z rho into w is equal to 0. Yes, I am waiting for your answer. I am waiting for your answer. This is the continuity equation which is valid for which type of flow? Everyone, बताइए. These are PYQs for engineering science from the topic of fluid kinematics, and very, very important topic for your GATE examination. Because in this equation del rho by del t is equal to 0, it means the flow must be steady, plus it can be compressible or it can be incompressible. Yes, what is the answer? Everyone, please do respond. And steady plus incompressible also, isn't it? Now, so steady plus incompressible, steady plus compressible. P and R are there. Now, try to understand this expression del u by del x plus del v by del y plus del w by del z is equal to 0. That is valid for incompressible. This is valid for incompressible, isn't it? This is valid for incompressible. If we multiply by rho on left and right hand side, yes, rho is constant. For incompressible flow, rho is constant. So it will be 0 again. So if we can take rho inside, then our expression will become this only. Are you getting it? Then our expression will become this only. So this is also valid for unsteady, even if it is unsteady, but it must be incompressible, isn't it? Unsteady and incompressible. Sorry. For unsteady compressible, it will not be correct, isn't it? Whenever the flow is unsteady, then del rho by del t must be non-zero. When the flow is unsteady, then del rho by del t is non-zero. But if the flow is unsteady but incompressible, then then we can say rho is constant, so del rho by del T will be 0. P, Q, R are correct, isn't it? Hi Hari, I am good, good, good. How are you? Crazy, समझ में आया आपको? Did you understand this or not? Is this clear or not? P, Q and R are correct. S correct नहीं होगा, because if the flow is unsteady, it means the fluid behavior changes with time. Del rho by del T is non-zero. If it is compressible, it means rho is not constant. So there has to be a term del rho by del T also. That is why S is not correct, but yes, Q is correct. Q can be correct. If density is constant, then even if the flow is steady or unsteady, del rho by del T will be 0. For all the incompressible flow, del rho by del T will be 0 because rho is constant. It is neither be a function of space nor time. So P, Q, R are the correct answers. I hope it is clear to everyone. Option A. What about question number 2? This was asked in GATE 2009. Question number 2 on the screen. Stream function cannot be defined. Stream function is a function of, it is defined only for two-dimensional. It is defined only for two-dimensional flow, isn't it? Stream function is defined only for two-dimensional flow. So it cannot be defined for three-dimensional flow. It cannot be defined for 3D flows, three-dimensional incompressible flow. Axis symmetric is rotational symmetry about one axis. So it can be considered as two-dimensional. So it can be considered as two-dimensional only. So C is the correct answer for question number 2. Question number 3 on the screen. Question number 3. Try to solve question number 3. Very, very beautiful question. Everyone, please give it a try. ये क्वेश्चन कौन सॉल्व करके बताएगा? Consider incompressible flow. What is the meaning of incompressible flow? Density is constant through a two-dimensional open channel. At a certain section AA, the velocity profile is parabolic, neglecting air resistance at the free surface. Neglecting the air resistance at the free surface, find the volume flow rate per unit width. Width is unity of the channel. First of all, we need to, this is the velocity in x direction u and this is y direction. So first of all, we need to develop a relation between u and y. What will be the answer for this one? Question number 3. 3 का आंसर बता रहे क्या हरी? मेंशन करिए आप 3 का आंसर बता रहे हैं, 2 का आंसर बता रहे हैं ऑप्शन सी, क्योंकि पिछले क्वेश्चन का आंसर ऑप्शन सी था. आर यू टॉकिंग अबाउट 3 और 2? यस एवरीवन. थ्री का आंसर. सबसे पहले u और y में रिलेशन डेवलप करेंगे. सबसे पहले u और y में रिलेशन डेवलप करेंगे. और वो कैसे करेंगे? कैन वी से u square is equal to ay, because y is positive. U square is equal to ay. Can we write u square is equal to ay? At y is equal to 0, u is equal to 0. And at y is equal to 2 meter, u is equal to 10 meter per second. So at y is equal to 2 meter, u is equal to 10 meter per second. So it will be 10 square is equal to a into 2. So from here a will be equal to 50. From here a will be 50, isn't it? So our expression is u square is equal to 50y. First of all, develop a relation or the parabolic expression. U square is equal to 50y. Now, जस्ट होल्ड ऑन। उसके बाद क्या करेंगे, at any y take dy. So from this, what is the discharge? dq is equal to u into dy into 1. Yes or no? U square is equal to 50y is the expression. So integrate this from y is equal to 0 to 2. So q will be equal to u is equal to under root of 50y into dy, and then integration to 0 to 2. Can you do the calculation? Root 50 into y to the power 3 by 2 into 2 by 3, and the limit will be 0 to 2. So it will be 2 root 50 by 3 into 2 to the power 1.5 meter cube per second. That will be the discharge. What is the answer for the discharge? What will be the value for the discharge? हाँ बताइए, what will be the answer? Isn't it 13.33 meter per second? Isn't it 13.33 meter per second? Yes or no? Are you getting it or not? B is the correct answer. Option B will be the right answer. B will be the answer for this one. So nobody had given me the correct answer. Kumar, समझ में आया? Why option B is correct? How? The first step is to develop the relation between u and y, which is parabola, and then do the integration for calculation of discharge. The next question, common data question. This was also asked in 2009. The velocity field for a two-dimensional flow is given by this expression. If we relate it with general velocity profile, then u is equal to x by t and v is equal to minus y by t. These are the value of u and v. Now the total acceleration is what? The total acceleration a is equal to ax I cap plus ay j cap. Find out the value of ax and ay. What is ax? Calculate the value of ax. Ax is equal to del u by del t plus u into del u by del x plus v into del u by del y. Because what is del u by del t? Del u by del t is equal to x into minus 1 into t to the power minus 2. Yes or no? Plus u, that is x by t. Del u by del x is 1 by t, and this term will be 0 because u is not a function of y. So ax will be equal to minus x by t square plus x by t square. So ax will be 0. Ax will be equal to 0. Yes or no? So I cap term will not be there. I cap term will not be there. I cap term will not be there. The only option is D. Yes or no? Ax will be equal to 0. Similarly, you can find out ay also. Ay is equal to del v by del t plus u into del v by del x plus v into del v by del y. U is equal to x by t and v is equal to minus y by t. Del v by del t is equal to minus y into minus 1 into t to the power minus 2. This term will be 0 because v is not a function of x, plus v minus y by t, del v by del y minus 1 by t. What is that? Minus minus plus y by t square plus y by t square. So it will be 2y by t square. Ay will be equal to 2y by t square. So acceleration is equal to ax I cap plus ay j cap, this is 0 and acceleration vector is 2y by t square into j cap. Yes or no? That is the answer. This will be the answer. So we could have already got the correct answer by calculating AX. Once you calculate AX correctly, then you can rule out the options which cannot be correct. D will be the correct answer. I hope it is clear. The second part of the question is, the given velocity field is incompressible, rotational, compressible, rotational, incompressible and irrotational, and compressible and irrotational. Bataiye. What about the second part? This is our expression. So for incompressible flow, del u by del x plus del v by del y must be 0, isn't it? That is the continuity equation for incompressible flow. Del u by del x is equal to 1 by t plus del v by del y is equal to minus 1 by t is equal to 0. RHS. LHS is equal to RHS. So the flow is incompressible. The flow is incompressible. And for irrotational, vorticity about z axis, del v by del x minus del u by del y is equal to 0 for irrotational flow. So del v by del x, it is 0 because v is not a function of x and u is not a function of y. Minus 0 is equal to 0. That is why the flow is irrotational also. So it is incompressible and irrotational. The flow is incompressible and irrotational. I hope this is clear. Is this all fine with everyone? Let me know the answer to the next one. This was asked in 2010. Next question. Is the flow steady or unsteady? So this flow is unsteady plus incompressible and plus irrotational. The flow is unsteady plus incompressible plus irrotational, isn't it? Why it is unsteady? Because u is a function of time, v is a function of time, velocity is a function of time. That is why it is unsteady. That is why the flow is unsteady. Let phi and psi represents the velocity potential function and stream function of a fluid flow, of a flow field of an incompressible fluid. Which one of the following statements are true? Phi exists only for irrotational flow. That is true. That is why potential flow is also called as ideal flow. Potential flow is also called as ideal flow because potential function exists only for irrotational, but stream function exists both for irrotational and rotational. So if psi satisfies Laplace equation, what is Laplace equation? Del square psi is equal to 0. Then the flow is irrotational. And if del square psi is not equal to 0, then the flow is rotational. So stream function is valid for rotational as well as irrotational flow both, whereas the velocity potential function is only valid for irrotational flow, and P and Q are the correct answer. P and Q. Option D. Nobody had responded for question number 6. Very simple, standard question. Velocity potential function exists only for irrotational but 3-dimensional, whereas stream function exists only exists for both rotational as well as irrotational flow, but the flow must be 2-dimensional only. These are the conditions. Can anybody give me the answer for this one? Can anybody give me the answer, correct answer for this one? The wind is blowing east to west at time t, which is less than capital T, and switches to south north at time t is equal to capital T. At t which is greater than capital T, which one of the following curves represents the streak line? Can you let me know the answer? Who will give me the correct answer will get a chocolate. Everyone, please give it a try. Streak line. It is about the streak line. You may not find questions from the streak lines. Mostly you find the questions from the streamlines. But if you are clear with the definition or the physical significance of a streak line, you will be able to get the correct answer. Initially, the wind is blowing from east to west, and then it is blowing from south to north. After, at t is equal to capital T, then what will be the representation of the streak lines? तुक्का मारा है हरि सिंधु? तुक्का या फिर you applied the logic? Yes. Try to understand. कैसे इसको समझेंगे? By taking some values. For an example, capital T is equal to, let us say, 5 seconds. So for t is equal to less than t, the wind is blowing from east to west, right? The wind is blowing from east to west like this. What is a streak line? First of all, you need to understand what is a streak line. Streak line is the locus of the fluid particles at any instant which must have passed through a fixed point. It is the locus of the fluid particles at any particular instant which must have passed through a fixed point. Let me call this to be a fixed point. So this at t is equal to 0. At t is equal to 0, this particle is moving from east to west, isn't it like this? At t is equal to, it will be reaching here. At t is equal to 2, it will be reaching here. And at t is equal to 3, it is reaching here. And at t is equal to 4, it is reaching here. And at t is equal to 5, it is reaching here. Isn't it? So fluid particle 1. After 1 second, I am observing the another fluid particle which is passing through this point. At t is equal to 1, the another particle is here only. At t is equal to 2, the particle will be here. At t is equal to 3, the particle will be here. At t is equal to 4, the particle will be here. And t is equal to 5, the particle will be here. So the first particle was here. This is, let me call it as number 1 particle. This is particle number 2, which is here at t is equal to 5, particle number 2. If I take another fluid particle, particle number 3, at t is equal to 2, I have put another particle. At t is equal to 3, it will reach here. T is equal to 4, it will reach here. And t is equal to 5, it is going to reach here. This is particle number 3. Similarly, particle number 4, which is also passing through this fixed point. So at t is equal to 3, I am observing the particle 4 which is passing through here. T is equal to 4, it will be here. T is equal to 5, it will be here. This is particle number 4. And again particle number 5, T is equal to 4, particle number 5, T is equal to 5, it will be here like this. So these are the particles which are at t is equal to 5. And when t is equal to 5 seconds, then the fluid will start flowing from south to north, isn't it? The wind is blowing from south to north. So at t is equal to 6, this will be reaching here. Particle 1, number 1 will be reaching here. Particle number 2 will also moving like this. At t is equal to 6, it will be here. Particle number 3 will be here. Particle number 4 will be here. Particle number 5 will be here. And particle number 6 will be here like this. At t is equal to 7 seconds, they will be moving up. This is particle number 1. This will be particle number 2. This will be particle number 3. This will be particle number 4. This will be particle number 5. This will be particle number 6. So at any time which is greater than t, what will be the position of the particle which started from the fixed point? Do you agree this is the line joining these particles? This is called as a streak line. Yes or no? At t is equal to 7, this is the streak line. At t is equal to 6, this will be the streak line. Yes or no? Do you understand it? So the representation of the streak line will be A. Is this clear or not? The locus of the particles which have started from the fixed point. Do you guys understand it? Yes? Everyone, please do let me know if you understood it. Please give me thumbs up. And please do not forget to like, share and subscribe our BYJU'S channel, so that this session reaches to all the students who are seriously preparing for GATE 2024. The next question you are supposed to solve. Everyone, give it a try. The velocity field for a two-dimensional fluid flow is given by, the velocity in x direction is given by this expression, and velocity in y direction is given by this expression, where u0 and L are the characteristic velocity and the length respectively. If the length is 0.2 meter and the resultant of total acceleration in x and y direction at x is equal to L and y is equal to L is 10, what is that acceleration? That is under root of ax square plus ay square is equal to 10. Then you need to find out the magnitude of u0. Then you need to find out the magnitude of u0. Can you do that? So first of all, you need to find out ax. The flow is steady, isn't it a steady flow? Why the flow is steady? Because the velocity does not change with time. Time is not a variable here. So the flow is steady, so local acceleration will be 0. So if we calculate ax, del u by del t, which is 0, plus u into del u by del x plus v into del u by del y, this will be 0 because it is a steady flow. U is u naught x by L plus v, into del u by del x. Into del u by del x is u naught by L plus v. V is not, u is not a function of y. This will be 0 because u is not a function of y. So it will be u naught square x upon L square. This is ax. At x is equal to L and y is equal to L, ax will be equal to u naught square by L. हरी जो फाइनल डायरेक्शन होगा उसके परपेंडिकुलर स्ट्रीक लाइन बनेगी. जो फाइनल डायरेक्शन है, जो भी फाइनल डायरेक्शन होगा, जैसे फाइनल डायरेक्शन साउथ से ईस्ट है, साउथ से नॉर्थ है, साउथ टू नॉर्थ है फाइनल डायरेक्शन, तो इसके परपेंडिकुलर स्ट्रीक लाइन बन जाएगा. वर्टिकल तब बनता जब इनिशियली साउथ से नॉर्थ फ्लो करता और फाइनली ईस्ट से वेस्ट. राइट? ax. And what about ay? Can you solve for ay? Del v by del t plus u into del v by del x plus v into del v by del y. V is not a function of x. This will be 0. This will be 0 because it is steady flow. So v is minus u naught y by L into del v by del y minus u naught by L. So ay की वैल्यू होगी u naught square upon L square into y. So at x is equal to L, y is equal to L, ay will be equal to u naught square by L. Y की वैल्यू L पुट कर देंगे. So ax and ay are these, right? Yes. Is this clear? Now magnitude of acceleration is equal to under root of ax square plus ay square. So that means 10 is equal to under root of u naught square by L plus u naught square by L. So it will be square. So it will be 2 u naught square by L whole square. So it will be 10 is equal to u naught square by L into root 2. Put the values. So u naught square is equal to 10 into L. What is the value of L? Upon root 2. L is equal to 0.2. L will be equal to 0.2. So u naught is equal to under root of 10 into 0.2 upon root 2. What is the answer? Can you solve it? 10 into 0.2, that is 2 by root 2. 2 divided by under root 2. And take the root of this. 1.189. 1.189. 1.189 will be the correct answer. Is this clear or not? This question was asked in GATE 2010. Now the above fluid can be described as rotational, compressible, irrotational. ये आप खुद से कर लेंगे. Find out del u by del x plus del v by del y. Del u by del x is u naught by L plus del v by del y is equal to minus u naught by L is equal to 0. It means incompressible. It is incompressible. A and B cannot be correct. Then for rotational, del v by del x minus del u by del y, ये check करिए. Del v by del x, v is not a function of x, 0, minus u is not a function of y, 0 is equal to 0. So it is irrotational also. So the flow is irrotational and incompressible. The flow will be irrotational and incompressible, isn't it? Question number 9. Now the next question, question number 10, beautiful question, asked in GATE 2011. Can you give it a try? Question number 10. The temperature field in a fluid flow is given by 60 minus 0.2 xy degree Celsius. This is the temperature. The velocity field is given by this 2xy plus tyj cap. It means it is unsteady flow. The flow is unsteady and two-dimensional. The rate of change of temperature measured by a thermometer moving along with the flow at x is equal to 2, y is equal to minus 4 and t is equal to 4 seconds is. We need to find out the rate of change of temperature. It means dt by dt is equal to how much in degree Celsius per second. Capital T is used for the temperature and small t is used for the time. So we need to find out capital T dt by dt. That is what is required. So we can say as t is a function of x, y and t. Temperature can be a function of x, y and t. So if we differentiate this, then we will get dt by dt is equal to del t by del x into dx by dt first term plus del t by del y into dy by dt second term plus del t by del t into dt by dt third term, isn't it? And what is this dx by dt? That is velocity in x direction, dy by dt velocity in y direction. These two will get cancelled out. So we can say dt by dt is equal to u into del t by del x plus v into del t by del y plus del t by del t. This. What is u? 2xy. What is v? That is ty. So that is equal to U is equal to 2xy into del T by del X. Temperature is a function of X and Y. So what is del T by del X? That is equal to minus 0.2y. What is del T by del Y? That is equal to minus 0.2x. Yes or no? Put these values. Del T by del X minus 0.2y plus V, that is T into Y. Then del T by del Y is minus 0.2x, and del T by del T, this will be 0. So if you put the values, how much is that? Let us first calculate it further. 2 into 0.2 minus 0.4 x into y square minus 0.2 x y t, that is dt by dt, and put the value x is equal to 2, y is equal to minus 4 and t is equal to 4. Put the value and let me know the answer. Put the value x is equal to 2, y is equal to minus 4 and t is equal to 4. What will be the answer? Put the value x is equal to 2, y is equal to minus 4 and t is equal to 4. So it will be minus 0.4, x is equal to 2 and y is equal to minus 4 square, minus 0.2, x is equal to 2, y is equal to minus 4 into 4. How much is that? What is the answer? It will be, can you solve it? Can you solve it and let me know the answer? Isn't it minus 6.4 degrees Celsius per second? Isn't it minus 6.4 degrees Celsius per second? Yes or no? Are you getting it or not? Minus 6.4 degrees Celsius per second. C is the answer. Yes, crazy. Well done. C will be the answer for this one. The next question is simple. Question number 11. A velocity field in a plane flow is given by this expression. The vorticity at a point 2, 4. The vorticity about z-axis, that is del v by del x minus del u by del y. What is del v by del x? This is v, that is 0, minus what is del u by del y? Del u by del y, that is 2x. 0 minus 2 into 2, that is minus 4 k radian per second, that is minus 4 k, minus 4. A is the answer. Vorticity. If the question would have been to find out the angular velocity, it would have been, this would have been angular velocity, omega z. Why? Because omega z is equal to half of vorticity about z axis. Angular velocity is half of vorticity. The next one, question number 12, asked in 2011. A fluid with a volumetric flow rate, that is the discharge 5 meter cube per second, enters the nozzle. Here it is entering the nozzle shown below. The cross sectional area varies as A is a function of x. This is 1 upon 1 plus x square. Assume that the flow is parallel and uniform at every section. The acceleration at any point in the nozzle is given by, at any x, acceleration. We need to find out acceleration at any x. We can say Vx into del Vx by del x. That is the acceleration. Convective acceleration. Because the discharge is constant. The flow is steady. And if the flow is steady, local acceleration will be 0. So it is the convective acceleration. So Q can be written as Ax into Vx, isn't it? So Vx is equal to Q by Ax. Put the value. So acceleration, convective acceleration is given by Vx, that is Q by Ax, into del by del x, Vx is again q by ax. So it will be q square upon ax into del by del x 1 upon ax. That will be the expression. And what is 1 upon ax? Isn't it 1 plus x square? That is 1 by ax, 1 plus x square. So it will be q square upon 1 plus x square, that is ax, into del by del x, differentiation of 1 by ax, that is 1 plus x square. So it will be q square into 1 plus x square. And what is the differentiation of this? This will be 2x. So the final expression is, convective acceleration is 2q square into x plus x cube, isn't it? 2 into what is q? Q is 5. So it will be 5 square into x plus x cube. So ax, convective acceleration, is 50 x plus x cube. Option A. A will be the answer, isn't it? Option A will be the answer. The next question is very important. The next question is very important. In an inviscid incompressible flow, non-viscous incompressible flow, the velocity field is given by this expression, xi cap plus yj cap, and the body force per unit mass is given by acceleration due to gravity. The pressure at the point 0, 0, is 101 Pascal. Assuming that the density of the fluid is 1 kg per meter square, the pressure at the point 1, 1, for this flow is. So how to start? This was asked in GATE 2011. This is wonderful question. We need to find out the pressure at a point 1, 1. So we can say, as pressure is a function of x, y, z, pressure is a function of x, y, z, isn't it? We can say pressure will be a function of x, y, and z. If we differentiate this, then we will say dp is equal to del p by del x into dx plus del p by del y into dy plus del p by del z into dz. Yes or no? Now can we find out del p by del x, del p by del y, del p by del z? From the rigid body motion, del p by del x is equal to minus rho ax, del p by del y is equal to minus rho ay, and del p by del z is equal to rho into g, right? So this is our equation number 1. We will calculate ax, ay, and g is already given. So what is ax? U is equal to, let us find out ax. U is equal to x and v is equal to y. Ax is equal to u into del u by del x plus v into del v by del u by del y. Sorry, del u by del y, isn't it? Because del u by del t will be equal to 0 because u is not a function of time. So u into del u by del x, so x into 1, and u is not a function of y, that is 0. So ax will be equal to x. Similarly ay, calculate ay, that is u into del v by del x plus v into del v by del y. Here this will be 0 because v is not a function of x. So ay will be equal to y. Yes or no? Ax is x, ay is y, and az is equal to minus 10, or g is equal to minus 10, that is given. G is equal to minus 10. So if we put the value dp is equal to del p by del x is equal to minus rho into ax, dx plus minus rho into ay into dy plus rho into g into dz, isn't it? So if you put the values, then dp is equal to, if we take minus rho common, minus rho, ax is x into dx plus y into dy minus, that is minus 10 into dz. Yes or no? So dp will be equal to minus rho. If we take the integration, if we integrate from 1 to 2, if we integrate from 1 to 2, if we integrate this 1 to 2, so it will be p2 minus p1 on the left hand side is equal to minus rho, then it will be x square by 2 plus y square by 2 plus 10 into z, and the limit will be from 0 to 1, 0 to 1. So if you put the limit, so p2 is equal to p1 minus rho, then 1 by 2 plus 1 by 2 plus 10. Yes or no? Plus 10. So what is p1? That is at 0, 0, 0. So p2, which is 1, 1, 1 is equal to, what is p1? P1 is 101 Pascal, 101 Pascal, 101 minus, what is the density? Density is given as 1 kg per meter cube, 1 into half plus half, that is 1 plus 10, 11. Yes or no? So 101 minus 11 Pascal will be the answer. How much is that? P2 is equal to 90 Pascal. Are you getting it? The answer will be 90 Pascal. D will be the correct answer, 90 Pascal. Is this all clear or not? Did you guys understand this question? It is about the partial derivative only. So I will provide the PDF of this session to my Telegram channel. If you are not part of my Telegram channel yet, please do join me on the Telegram, which will help you to revise these questions again, try to solve these questions again at home. The next one, a flow has a velocity field given by this expression, that is u I cap plus v j cap. The velocity potential function for the flow is, phi is a function of, as we know, phi is a function of x and y. So if we differentiate this, then d phi will be equal to del phi by del x into dx plus del phi by del y into dy. Yes, and u is equal to minus of del phi by del x, and v is equal to minus del phi by del y. What is u? That is equal to 2x. What is v? That is equal to minus 2y. So del phi by del x, so d phi is equal to, what is the value of del phi by del x? That is minus 2x dx. Then what is del phi by del y? That is 2y into dy. If we integrate this, then integrate this, so phi will be equal to minus 2 x square by 2 plus 2 y square by 2. So implies phi will be equal to, phi can be taken as minus x square plus y square. This is the velocity potential function, or we can say phi is equal to x square minus y square, one and the same thing. Multiply a whole equation with minus 1. So it is not x square plus y square plus constant. We can put constant also. It is not this, it is not this. It is x square minus y square plus constant. D will be the answer. D will be the correct answer. And the streamlines for the velocity field look like streamline. Find out the stream function. Psi is also a function of x and y. So d psi is equal to del psi by del x into dx plus del psi by del y into dy. Now we know u is equal to del psi by del y. What is that? U is equal to 2x. And v is equal to minus of del psi by del x. That is equal to v is how much? That is minus 2y. Isn't it? So d psi is equal to del psi by del x. Del psi by del x is equal to 2y dx plus del psi by del y is equal to 2x dy. Now if we integrate this, then psi is equal to 2xy plus 2xy. So we can say psi is equal to xy or 2xy. So it is a rectangular hyperbola. Isn't it a rectangular hyperbola? Which is the correct representation? Tell me, which will be the correct representation for stream function or the streamlines? Isn't it option D? Isn't it option E? It is not a straight line. It is not a circular path. It will be rectangular hyperbola. Psi is equal to xy or psi is equal to 2xy. Can you solve the next one? Question number 16. The velocity in 1D unsteady flow is given by this x square minus t. The total acceleration at any x and t is total acceleration. So what is the total acceleration? Local plus convective. It is 1D flow. The total acceleration is local plus convective. So the total acceleration is del u by del t plus u into, or let me write it as del v. Del v by del t plus v into del v by del x, isn't it? That is the acceleration. So what is del v by del t? That is minus 1, that is the velocity, minus 1 plus v, that is x square minus t, del v by del x, that is 2x. So it will be minus 1 plus 2x cube minus 2tx, that is acceleration. D. Yes, it is D. Well done. Good. This is your assignment question. In the following equation, u and v are the velocity in x and y direction. This was asked in 2012. And t is the time. The flow field that cannot be termed as incompressible. So for incompressible flow, use the continuity equation for incompressible flow. What is the continuity equation for incompressible flow? Del u by del x plus del v by del y is equal to 0. The flow which is not satisfying this equation will be not incompressible, which cannot be incompressible. So please check each and every option. And one more question, I am giving you the assignment. This is one of the assignment, try to solve. And another assignment is this. Try to solve this question and share me the answer through the Telegram channel. All right. And tomorrow get yourself ready for fluid dynamics previous year questions. We will discuss the questions from the fluid dynamics engineering science paper in tomorrow's session at 5 p.m. All right. And we are running mega mock test for GATE 2024 aspirants. There are 4 subject-wise tests. Do appear for this test, and based on your performance in the subject-wise test, you can unlock our test series also for the very cheap prices. And you can, if you are interested to be part of our paid course, the right guidance is very much important for clearing any competitive examination. So do join our paid course for getting the sure success in your GATE or any other competitive examination. All right, you can connect with the mentioned number for more details about our various paid batches. This is my mail ID and this is my link to join the Telegram. So that is all from my side, guys. You can also scan the QR code. So please do like and share this session. And that is all from my side. See you in the next class. Till then, enjoy. Engineering science paper. XE means engineering science. Okay. Fluid mechanics is one of the subject in engineering science. Fluid mechanics, strength of materials, thermodynamics. These are the subjects which are asked, and mathematics. This is the syllabus of engineering science paper, because you are having 2 paper combination. So you should appear for the engineering science paper as well. All right. So that is all from my side. Thank you. Enjoy. Take care. Have a good day and a great career ahead. Jai Hind. See you tomorrow at 5.